In this presentation, we will consider the example of calculating the Schwarzschild radius as an example of using scientific notation in Excel. The Schwarzschild radius calculation comes from relativity theory, but it's a pretty simple calculation of 2 times g times m divided by c squared, where g is a constant and c is a constant and m is the mass of some object, usually some astronomical object. For this exercise, we're grabbing the data from the Wikipedia page on the Schwarzschild radius. Remember when copying the data to highlight only the interior of the table, and then over in Excel, sort of get up into cell A1 and right-click, and it's probably easiest if we choose the match destination formatting, then we won't get any hyperlinks and so on. So we'd like to do some quick formatting at this stage, so we want to highlight all the cells on the sheet, and to do that we click on that little square that is the gray square that is above the 1 and to the left of the A, and then that highlights all the cells, and then we can put our cursor in the gray area, but it will turn green, between two columns, say between A and B, and when we're in the right place it will become a double-headed arrow, and then we can double click and that will give us enough space for all the columns. Now we want to do the Schwarzschild radius calculation for ourselves, but we can see that we have a problem right away, and that the masses in column B are not recognized as numbers by Excel. We can tell that by the fact that they're left justified, whereas Excel would right justify numbers. The first problem we're going to encounter is that whoever made up this data table put the unit of kilograms in each cell in the table. So one lesson to learn is that if you are creating some table that you wish people to use, don't do that. It is easy enough to just put the unit into the header at the top in cell B1, and then it will be understood for all of the data below. So it's unnecessary and sort of annoying to put the unit in all of the cells. And if the unit were changing, that would be confusing. So you should, work out the numbers, and scientific notation is good for this, that you can keep one unit, and then if the numbers are very big or very small, that's what we use scientific notation for. The other lesson here is that there's a lot of things we need to change here. kg is appearing a lot of times, and we're going to use a quick find and replace approach rather than go in and type, edit each cell individually. Before fixing the data in column B to make it numbers that we can calculate with, we're just going to make room for the calculation. So we've inserted a new column C, and then we're entering the header as the formula for our calculation, which is 2gm divided by c squared. And if you want that square to look like a square, if you want it to be superscripted, then under the home menu, you can click on that in the font region, you can click on that little font settings button to bring up the format cells dialog box, and you will see in there a checkbox to make it superscript. Now let's get rid of those kilogram units, those kgs that appear in column B. So highlight one of the cells and highlight the kg, and there happens to be a little space before the kg, and it'll be important to grab that. And I say a space, but I'm not sure it's a space. It could be a tab or something else. So that's why it's useful to highlight it and copy it rather than assume I know what it is and type it for myself. And then once you've highlighted it and copied it, then go to the Find and Select drop-down on the menu. Make sure Home's selected, and then as the main menu item, and then you will find over on the right a Find and Select drop-down list, and there choose Replace. That will bring up the Find and Replace dialog box, and in the Find What, we are going to paste in that what we copied, space kg or maybe tab kg, again, whatever. And then we're going to, in the replace with, we're going to replace it with nothing. So type nothing in the replace with box, and then hit the replace all button. So now we look at the result and we see that column B is still left justified. Excel does not recognize those as numbers still. So the next lesson to learn, lesson 3 to learn here, is that Excel, and in general most computer languages, represent scientific notation differently. So you would not say 8.8 times 10 raised to the 52 as shown in cell B2, but the proper scientific notation as far as Excel is concerned is 8.8 E52. So instead of saying times 10, it replaces that with an E. And so then we return to lesson 2. We have a number of things to replace, times and 10, and we want to replace them with E, and so we'll do this sort of nice global find and replace approach. So again, we go to the data and we will copy what we want replaced, and it is times 10, and which we want to replace with E. We're going to copy it. We don't know if that's a time symbol or an X. We don't know what the person who made this table typed, and so it's best to copy, and then we don't have to know we are copying whatever it is they typed. And so then the same instructions as before. With home selected, go over to the far right, find the find and select, and drop down and then choose replace, and in the find and replace dialog box, paste in the times X in the find what, and this time we are replacing it with something, we're replacing it with an E, and hit the replace all button. The last 3 entries are still not numbers. In lines 13 and 14, instead of writing kg as they did in all the cells above, they decided to write out kilograms, so we need to delete kilograms. It's only 2 entries this time, so it's probably just as sufficient to just edit the cells and delete kilogram. And the problem with the entry in B15 is it looks like E minus 8, but that's actually not a minus. That's probably a dash, and that's a common thing that happens in different formattings. The length of the dash is a different symbol, and so the longer dash is easier to see, but you come over to Excel and it's not a minus sign, so we have to go in and replace that dash with a minus sign, and then it will be understood as a number. Now that we have the masses understood as numbers in column B, we need to introduce the other numbers in the calculation, the constants, the gravitational constant G and the speed of light C. And so I've inserted a few rows, and in C1 and in C2 I have entered the numbers, and I've entered them in scientific notation. And you see in cell C2 that I typed in 2.998E8, and then Excel on its own converted that to a sort of more integer representation of the number. So it took it out of scientific notation. That number was small enough to be represented as an integer, and Excel decided that that was better, and so it replaced it. And so now we're finally ready to perform the calculation. So in cell C5, we are entering the formula equals 2 times $C $1 times B5 divided by $C $2 caret 2. We note that the constants, which were in C1 and C2, get $, so that when the formula is copied down, those numbers will not change. So as we move from row 5 to row 6, $C $1 will remain $C $1, and the same thing, $C $2 will remain $C $2. On the other hand, the mass variable, which was in B5, will get updated to B6, and so that will allow the mass, not having $, will allow the mass variable to be a variable to vary.